Okay, so we are working our way through the Kaplan 2012 GED plus. Well, I think any of the Kaplan books would be fine. We're going through one of the practice tests by subject, and question 10 on the practice test is a tough one, but there's a way to win. So what we have to do is factoring polynomials or factoring expressions. And that's why I've said Unit 2, Chapter 6, page 360, kind of. They talk about quadratic equations, some other junk. But here's what we want to do to solve that big old problem. And I'll write the problem or something like it up on the screen in a second. We got to remember dear Aunt Sally. She says, we're doing this thing on the left first. She says parentheses first, right? But in this problem, 3x plus 4, we can't do anything because we don't know what x is. But 2 is waiting out here, and an invisible times sign there, an invisible multiplication dot. So we're going to jump the fence. We had talked about this before on, question 3 about FOIL. So this 2 is going to jump the fence and go 2 is going to go 2 times 3x. And again, what do? We do what we can. Can we say 2 times 3? We can, and get a 6. And then the x comes traveling along. It's got nothing else to do, so it follows the 6. And then 2 times positive 4 is positive 8. And then how do we know we're done? Because it says this is simplifying, not solving. We're not going to figure out what x is. There's no equal sign. If we have forks, knives, spoons, we're done. We got the X families all together and the just a number families all together. So that is the distributive property, jumping the fence. That's how we get rid of those parentheses to keep dear Aunt Sally happy. Now, the opposite of that is what is factoring. So all I did was use the same answer, and now we're going to work backwards. The answer down here will end up being that. Now, the way we do that is a little tricky. What we're going to do is sort of hover over this part and this part and look for common things. And then we're going to take, it's like, it's kind of the exact opposite. We're going to pull out something that they have in common, which we know is going to be a 2. So 6 and 8. They're both even numbers. If we were to factor them out, factory means parts. If we were to pull out parts that they have common, they both have 2 in common, because 2 times 3 makes a 6, and 2 times 4 makes an 8, and they're both positive. And then, so we pulled the 2 out of that, and we pulled the 2 out of that. So 2 times 3 gives 6. 2 times 4 gives 8. X is only here, not here. So that's why it slides on down, and we're done. This rarely, I mean, we have to say forks, knives, spoons, and do the whole wedding story and all that stuff to feel like we're done there. This one is even tougher because this doesn't feel done at all. I mean, we just sort of rewrote something that in our brain we're like, well, this has multiplication left to do. So that's where factoring expressions, polynomials, can get really tricky, because it's sort of like taking something that's tied up and nice and then unsettling it a little bit. So this is undistributing, or whatever, whatever it is. So I'm gonna pause the video here, and I'm gonna write a different version or a different look of what the thing they wrote in the Kaplan book to show the walkthrough. But remember, the opposite of factoring this stuff, and I don't even think they called it factoring in the question. Yeah, they just said simplify. But doesn't matter. I'm gonna try to write it up the best I can. This is gonna take a second. Okay, so this is how we actually do factoring. It is the long way. It's the way I would not suggest doing it on the test, because there's an easier way and a faster way. So here's something that roughly looks like what's in the GED book for question number 10. So what we're going to do is, just like we did on that distribute thing, we're sort of going to hover over these three things and look for common parts. So the first thing is they all have numbers. They have 4, 2, and 4. We're ignoring the tiny little 2s. Ignore those for now. With just regular old numbers, they got 4, 2, and 4. We got to think, what do those things have in common? Well, 2 goes into all of them. 2 goes into 4 twice. 2 goes into 2 once. So we can take a 2. Now I'm building an answer key down here, so this is one of the answer choices. So this is where all the magic's going to happen down here. So I took out all the 2s, or a 2 from each of them, because I could. Now, let me take away from that. Are there x's in common? Well, the first one has an x squared, or x to the second power. This one has an, that means there's 2 x's here. Mm-hmm. There's 1 x here, no x's here, so I can't take any. So I got to leave the x's. Yeah, all these x's are going to come down and be untouched. Next, I got to look at y. Well, a y is here, a y is here, and it's y squared here, so there's 2 y's here. So I can take at least 1 from all of them. So that's why the y goes there. And now we build our parentheses. So what is left over when I took a 2y out of there? I took 2y out of there. What's left over? Well, I'm going to have to put a 2 here for the 4, because 2 times 2 is 4. See how aggravating this is? So yeah. This is tough. We don't have, we're not going to do it this way. This is not the way to do it on test. So 2 times 2 would be 4. The x squared gets to just come on down because we didn't take anything out of there. But we did take the y. The y is out here. Already up. So next one, 2xy, 2 times x times y. We took the 2 and the y out, so the only thing left over is the x, which goes there. So that one's done. And I'm going to hurry through this because, again, this is not the way to solve this, I don't think. Same thing here with the last one. 4, well, 2 times 2 is 4, so a 2 is going to go right here. And we took out one of the y's, so there's 2 y's here, so there's one y left to go here, and now we're done. And nothing looks satisfying about that. This is the way that I think is not the best way to answer this question. So I'm gonna pause and set you up for the best, what my advice is for the best way to answer this. So in order to feel different on the test, there are times when we want to, instead of feeling like we're taking a test, we want to feel like we're grading assignments. We're going to flip the question upside down. And I know there's usually 4 choices, and I only wrote 3. Here's my 3 choices. There are questions, and a lot of them, a lot of predictable questions on the test, where instead of doing the work of the question, grade the answers, put the answers on trial. And that will save a ton of time, because one answer has to be perfect, and all the other answers, they could be 99% right. That makes them 100% wrong. So all we have to do is look for a flaw. So the way we would do that in a question like this, instead of doing all this stuff and factoring the thing, take something we already know, which is jumping the fence. So, and distributing. We know this is the right answer. I haven't touched it. So we're going to put, but let's say we're not sure. We're going to put all these on trial. And they all, one of them, when we distribute out or jump the fence, is going to match this perfectly. So here we go. As long as we recognize these answers force us to distribute, to jump the fence, we're going to give it a shot. So here we go. I'm going to jump the fence. 2 times 2 is 4. And the rest of this stuff just comes down because there's nothing to multiply with. So 4x to the second power y. That matches that. So it did pretty good. Now we're going to jump this fence. 2 times 2 is 4, positive 4, so plus comes in. And there's nothing else to multiply it with, so the x and the y come on down. Like, okay, it's a contender. Oh, wait, no, it doesn't. because it can't be a 4, it's got to be a 2. So that right there, 2 times 2 got us 4. It can't be a 4, it's got to be a 2. We can stop. This one is definitely wrong. So I'm going to undo all this and just go, okay, I found a mistake. This can't be it. Now I'm going to look at this one. 2xy times 4x. And like, man, this is crazy. Well, do what you can. 2 times 4 is 8. It can't
You're
be 8.
right off the top.
It's got to be 4. That's got to be wrong. And then and we know the bottom one's right. 2 times 2 is 4. X squared times nothing is x squared, or times, don't have to times it with anything. And the y comes on down. That matches that, and boop, 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 all of these match. So there are going to be times where there's math to be done in the answers. Grade them. You won't feel like a student for a while. You'll feel like a test grader. You're going to feel like a teacher, and you are looking for perfection. So as soon as you saw one flaw, just whoop, throw that paper away, and that kid's not going to get his assignment put on the fridge because it's not perfect. You want to feel powerful. You want to think on question 32 out of a 46 question test, every once in a while, we want to change our mindset. So that very difficult problem in the book on page 596, question 10, all it says for instructions, simplify the following expression, and then gives it looks like a bunch of typos. It looks like a cat ran across a keyboard and just made up a bunch of numbers and letters. There's a chance to feel more powerful about that and feel positive. So put the answer on trial is a great strategy, especially for something like, instead of learning this other extra factoring thing, which is tough and tedious, you already know how to jump the fence. So apply that, and it's like getting a freebie. You guys can do this. We can do this, no doubt.